a production of Green Valley Educational Institute.
Welcome to the digital classes. We have to discuss a very important topic today, that is reactions of alkyl halides and aryl halides. Chemical properties of alkyl halides and aryl
A
halides.
production of Green Valley Educational Institute.
Chemical properties of haloalkanes called as alkyl halides. In common system, these are called as alkyl halides. Chemical properties of haloalkanes and haloarenes called as aryl halides. Very important chapter, chemical reactions of haloalkanes. We will be discussing today chemical properties of haloalkanes. I have got methane. If I replace H, if hydrogen is dropped and substituted by halogen, this compound will be called as haloalkane. X stands for halogen. X can be chlorine, it can be bromine, it can be iodine. So when you replace hydrogen atom or atoms from alkane and these are substituted by halogen or halogens, the compound is called as haloalkane, or we call this as alkyl halide. Today we are going to discuss the chemical properties of haloalkanes. What are the characteristic reactions of alkyl halides? The characteristic reactions of alkyl halides are nucleophilic substitution. Nucleophilic substitution. Alkyl halides undergo nucleophilic substitution. These are the characteristic reactions of alkyl halides. If I start with primary alkyl halide, carbon connected to one carbon is called as primary carbon. If primary carbon is connected with halogen, this will be called as primary alkyl halide, or X means alkyl halide. Now, bromine is more electronegative than carbon. Bromine pulls electrons more towards itself, has delta negative charge. Consequently, carbon has delta positive charge. This bond is polar. Now, if this compound is made to react with nucleophile, if this compound reacts with nucleophile, you know that nucleus loving species, positive charge loving species, Nu is General symbol of nucleophile. Positive charge loving species. Nucleophile will attack on this carbon because this carbon has positive charge. Bromine will leave the compound as bromide ion. Product is this. What is bromide ion? It is a nucleophile. I can say this nucleophile has substituted this nucleophile. We call this as nucleophilic substitution reaction. Nucleophilic substitution reaction. Now, it has been experimentally confirmed that speed of this reaction depends upon the concentration of alkyl halide as well as nucleophile. Speed of this reaction depends upon the concentration of alkyl halide as well as nucleophile. So, order of this reaction is 2. It is a second order reaction. This reaction follows second order kinetics. It is a second order reaction. Speed depends upon both alkyl halide as well as nucleophile. Now, it has been explained that this reaction involves SN2 mechanism. This reaction takes place by SN2 mechanism, bimolecular nucleophilic substitution mechanism, or we can simply say second order nucleophilic substitution mechanism. This reaction involves SN2 mechanism, which is a single step mechanism. This reaction involves single step mechanism. We call that mechanism as SN2 mechanism. Now, let us discuss the mechanism of this reaction. I have got Rx. Rx represents alkyl halide, haloalkane, plus nucleophile. Nucleophile establishes bond with carbon. We get transition state first. This is transition state. And finally we get the product. Product is this. Nucleophile attacks on the central carbon, establishes bond. There is partial bond making and partial bond breaking in the transition state. जो energy यहाँ पर release होती है when bond is partially formed, that energy is sufficient to break this bond. Finally, nucleophile establishes bond with carbon and X leaves the compound as X negative. This is the reaction. Experimentally, it has been confirmed that it is a second order reaction. Speed depends upon both reactants, alkyl halide as well as nucleophile. because this reaction involves single step mechanism. Since the mechanism involved is single step, इस रिएक्शन के मैकेनिज्म में एक ही स्टेप इन्वॉल्व है, एंड दैट स्टेप इज द रेट डिटरमाइनिंग स्टेप. एक ही स्टेप इन्वॉल्व है मैकेनिज्म में, एंड उस स्टेप को हम कहेंगे रेट डिटरमाइनिंग स्टेप. सिंस इन द रेट डिटरमाइनिंग स्टेप both reactants are involved, alkyl halide as well as nucleophile. Since in the rate determining step both reactants are involved, therefore speed will definitely depend upon both reactants, hence order of the reaction is 2. Now, what is the important event of SN2 mechanism? The important event of SN2 mechanism is that product formed has configuration. Product formed has configuration inverse of the reactant. There is inversion of configuration. Product formed has configuration which is inverse of the reactant. यानी अगर reactant में halogen attach है on front side, in the product nucleophile is attached on the back side of the central carbon. So what is the important event of SN2 mechanism? The important event is that product formed has configuration which is inverse of the reactant, and that is possible only when nucleophile attacks on the back side. When nucleophile attacks on the opposite side, to the side to which halogen is attached. alkyl halide में जिस साइड में halogen attach है, nucleophile attacks on back side to the side to which halogen is attached. Because when there is inversion of configuration, experimentally confirmed that product formed has configuration which is inverse of the reactant. यानी प्रोडक्ट में जो न्यूक्लियोफाइल अटैच होता है वो सेंट्रल कार्बन को अटैच होता है ऑन द अपोजिट साइड टू द साइड टू विच हैलोजन इज अटैच्ड इन द रिएक्टेंट. यानी अगर हैलोजन अटैच है कार्बन को ऑन फ्रंट साइड, प्रोडक्ट में न्यूक्लियोफाइल अटैच होता है ऑन बैक साइड ऑफ द सेंट्रल कार्बन. दैट्स कॉल्ड एज इन्वर्जन ऑफ कॉन्फिगरेशन. And that inversion of configuration is possible only when nucleophile attacks on backside. There is backside attack. That means nucleophile attacks on central carbon to the side to which it attacks on the opposite side to which halogen is attached. जिस साइड में halogen attach हो उसके back side में nucleophile attack करता है. Now the question is, what will be the order of reactivity of nucleophilic substitution? What will be the order of reactivity of nucleophilic substitution by SN2 mechanism for various alkyl halides? The order of reactivity is the order of reactivity will be primary alkyl halide greater than tertiary. When it is SN2 mechanism, SN2 mechanism involves backside attack. Therefore, the substrate of choice for nucleophilic substitution by SN2 mechanism is primary alkyl halide. Because if you take tertiary alkyl halide, If you take tertiary alkyl halide, if we take tertiary alkyl halide, suppose I have got this carbon connected to 3 carbon atoms, tertiary carbon. Tertiary carbon के साथ halogen, it is tertiary alkyl halide. In case of tertiary alkyl halide, nucleophile cannot attack on the backside, because nucleophile backside में क्यों नहीं अटैक कर सकता? Because central carbon is attached with bulky groups. Central carbon is attached with bulky groups. There is crowding of atoms around central carbon. There is crowding of atoms around central carbon. So backside attack will be hindered. That's called a steric hindrance. That's called a steric hindrance. So, as far as tertiary alkyl halide is concerned, it cannot show nucleophilic substitution by SN2 mechanism, because the important event of SN2 mechanism is backside attack. But in case of tertiary alkyl halide, nucleophile cannot attack on central carbon on the backside, because central carbon has bulky groups attached with it. There is crowding of atoms. So approach of nucleophile on the backside becomes difficult. We call this a steric hindrance. यानी tertiary alkyl halide का जो structure है, जो इसकी stereochemistry है, वो इस किस्म की है कि it will not allow backside attack by nucleophile. So tertiary alkyl halide will not show nucleophilic substitution by SN2 mechanism. As far as primary alkyl halide is concerned, primary alkyl halide mein, we know that in case of primary alkyl halide, nucleophile can easily attack on the backside, because there are simple atoms attached. These are hydrogen atoms. These are not the bulky groups. Therefore, nucleophile can easily attack on the backside. So, that's why the order of reactivity for nucleophilic substitution by SN2 mechanism will be primary, secondary, tertiary. Now, coming to the tertiary alkyl halides. If I take tertiary alkyl halide,
A production of Green Valley Educational Institute.
if I take tertiary alkyl halide, carbon connected with 3 carbon atoms, tertiary carbon, it is tertiary alkyl halide. Now, delta negative, delta positive, nucleophile establishes bond, product will be formed, experimentally it has been confirmed that nucleophilic substitution of tertiary alkyl halides, it is a first order reaction. First order reaction. This reaction follows first order kinetics, which means speed of this reaction depends upon the concentration of alkyl halide only. It has been experimentally confirmed that speed of this reaction depends upon the concentration of alkyl halide only and not on the concentration of nucleophile. Now the question is why? Why Cp depends upon the concentration of alkyl halide only, not on the concentration of nucleophile. This is because this reaction involves SN1 mechanism. First order nucleophilic substitution mechanism or unimolecular nucleophilic substitution mechanism. This reaction involves SN1 mechanism, which is a single step mechanism. This reaction involves this reaction involves SN2 mechanism, the SN1 mechanism, which is a two-step mechanism. This reaction involves SN1 mechanism, which is a two-step mechanism. इस रिएक्शन के मैकेनिज्म में दो स्टेप्स इन्वॉल्व है. लेट्स गो फॉर द मैकेनिज्म. SN1 mechanism. The first step is this. Carbon bromine bond breaks, heterolytic fission takes place. Bromine leaves the compound along with pair of electron. एक इलेक्ट्रॉन इसका अपना, एक इसने गेन किया. प्लस जब ये इलेक्ट्रॉन ब्रोमीन ने लिया, प्रोडक्ट इज दिस. इलेक्ट्रॉन ब्रोमीन ने लिया, कार्बन पर पॉजिटिव चार्ज. दिस इज कार्बोकैटाइन. Carbocation. The second step is that nucleophile attacks on carbocation and establishes bond. This is your product. Experimentally, it has been confirmed that speed of this reaction depends upon a concentration of alkyl halide only, not on the concentration of nucleophile. Therefore, this reaction is first order reaction. First order reaction. Why? Because this reaction involves SN1 mechanism, which is a two-step mechanism. Two-step mechanism. In the mechanism of this reaction, two steps are involved. In the mechanism of this reaction, two steps are involved. In the first step, carbon bromine bond breaks and we get carbocation. In the second step, nucleophile establishes bond with carbocation. Reaction ये है, involves SN1 mechanism, which is a two-step mechanism. Out of the two steps, first one is slow because it involves bond breaking. Bond breaking requires energy. This second step is fast because it involves bond making. Now, you know that from chemical kinetics point of view, out of the two steps, first one is slow, another is fast. Slow step is the rate determining step. That means अगर आप चाहते हो कि प्रोडक्ट जल्दी बन जाए तो कार्बोकैटायन जल्दी बनना चाहिए. This reaction involves two steps. Out of the two steps, one step is slow, another is fast. Slow step is called as rate determining step. That means like जैसे हम केमिकल काइनेटिक्स में एग्जांपल देते हैं, सपोज हम किसी फैक्ट्री में मोटर कार्स मैन्युफैक्चर करेंगे. हमने डिफरेंट सेक्शंस इस फैक्ट्री के रखे हैं. एक सेक्शन का काम आप इंजन बनाओ, दूसरे सेक्शन का काम आप ब्रेक्स बनाओ, अनदर इसी तरह से अलग अलग सेक्शंस, और एक सेक्शन का काम रखा है आप टायर बनाओ. शाम को हम अगर इस फैक्ट्री में जाते हैं, हम देखते हैं कि दिन में 1000 इंजन बन गए हैं. हॉर्न्स वी हैव गॉट 500, ब्रेक्स 10,000. लेकिन जब हम टायर डिपार्टमेंट में पहुंचते हैं, वी हैव गॉट ओनली टायर्स, ओनली 4 टायर्स मैन्युफैक्चर्ड ड्यूरिंग द डे. एक दिन में सिर्फ 4 टायर मैन्युफैक्चर हो गई. तो गाड़ियां कितनी मैन्युफैक्चर हो गई दिन में? 1, बिकॉज यू हैव गॉट ओनली 4 टायर्स. तो गाड़ियां कितनी बनी? 1. If we want to increase the rate of manufacture of motor cars, we should increase the rate of manufacture of tires. गाड़ी हमारा प्रोडक्ट है, मगर बनता है थ्रू डिफरेंट स्टेप्स. उसमें एक स्टेप टायर बनाने का स्टेप है, एंड वो स्लोएस्ट है. 4 ही टायर दिन में बनते हैं. अगर हम चाहते हैं कि ज्यादा से ज्यादा गाड़ियां दिन में बने, तो वी शुड इंक्रीज. 8 टायर बन गए, 2 गाड़ियां बन गई. सो rate of manufacture of cars is determined by rate of manufacture of tires. So rate of manufacture of tires becomes the rate determining step. Coming to our question, reaction ये है, but it takes place through 2 steps. Out of the 2 steps, one is slow. प्रोडक्ट किस रफ्तार पर बनेगा डिपेंड करेगा कार्बोकैटायन किस रफ्तार पर बढ़ेगा. If you want to increase the speed of manufacture of product, increase the rate of manufacture of carbocation. But rate of manufacture of carbocation depends upon the concentration of alkyl halide only, not on the concentration of nucleophile. If you increase the concentration of nucleophile or decrease the concentration of nucleophile, rate of reaction will not be influenced. A nucleophile has to be 8 till you get a carbocation. Speed of formation of product will depend upon speed of formation of carbocation, but that will depend upon the concentration of alkyl halide only, not on the concentration of nucleophile. Therefore, speed of this reaction depends upon the concentration of alkyl halide only, not on the concentration of nucleophile. Hence, order of the reaction is 1. It is a first order reaction. Now the question is, what is the important event of SN1 mechanism? The important event of SN1 mechanism is formation of carbocation. Important event of SN1 mechanism is formation of carbocation. Now the question is, order of reactivity क्या होगी इसमें? Look here. For SN2 mechanism, the order of reactivity will be tertiary greater than secondary greater than primary. Why? Because the important event of SN1 mechanism is formation of carbocation. Starting with the tertiary alkyl halide, we will get tertiary carbocation, which is highly stable, then secondary carbocation, which is highly stable, then primary carbocation. सो अगर हम टेरिशियरी अल्काइल हैलाइड लेंगे, वो क्या टेरिशियरी कार्बोकैटायन, ये जल्दी बनेगा बिकॉज ये स्टेबल है। अगर हम प्राइमरी अल्काइल हैलाइड लेंगे, उससे प्राइमरी कार्बोकैटायन बनेगा, वो बिल्कुल अनस्टेबल है। इसलिए अगर न्यूक्लियोफिलिक सब्स्टिट्यूशन अल्काइल हैलाइड्स का हो जाता है बाय SN1 मैकेनिज्म, द सबस्ट्रेट ऑफ चॉइस इज tertiary alkyl halide. Because starting from tertiary alkyl halide, we will get tertiary carbocation, which is highly stable, therefore will be prepared very fast. So this is the order of reactivity for nucleophilic substitution by SN1 mechanism. It is SN1 mechanism. I'm sorry, SN1 mechanism.
A production of Green Valley Educational Institute.
That alkyl halides can undergo nucleophilic substitution by two mechanisms, SN1 or SN2. If substitution takes place by SN1 mechanism, order of reactivity is tertiary secondary primary. If it takes place by SN2 mechanism, it is primary secondary tertiary. SN2 mechanism, single step mechanism. SN1 mechanism, two step mechanism. Now, when alkyl halide reacts with nucleophile, substitution can take place by SN1 or SN2. If it takes place by SN1, this is the order of reactivity. If it takes place by SN2, this is the order of reactivity. But alkyl halides also undergo elimination reactions. Substitution reactions are the characteristic reactions of alkyl halides, but alkyl halides can also undergo elimination. What is elimination also called as? It's also called as dehydrohalogenation. Elimination is also called as dehydrohalogenation, removal of hydrogen and halogen. But just as substitution can take place by SN1 or SN2, elimination can take place by E1 or E2. Elimination can take place by E1 or E2 mechanisms. What is E1 mechanism? Again, it is a single step mechanism. It is a carbocation mechanism. E1 mechanism is a single step mechanism. It is carbocation mechanism. I will explain it. I have got tertiary alkyl halide. Carbon connected to 3 carbon atoms, tertiary carbon. This is tertiary alkyl halide. If it is made to react with hydroxyl ion, hydroxyl ion is a nucleophile. It is a base, nucleophile as well as base. Now this hydroxyl ion eliminates H positive from the compound. This pair of electron will go to carbon chain, double bond is established. जब यहां पर डबल बॉन्ड एस्टैब्लिश होगा, ब्रोमाइड आयन लीव्स द कंपाउंड, वी गेट दिस प्रोडक्ट. Plus bromide ion, of course, minus water. This is dehydrohalogenation, loss of hydrogen and halogen. We also call this as elimination. This is elimination by single step mechanism. Now, यहां पर मैं वापस एक्सप्लेन करता हूं. Elimination can take place by even mechanism. Even mechanism is a two-step mechanism. It is a two-step mechanism, not one step. E1 is two-step mechanism, just as SN1 is two-step mechanism. E1 is two-step mechanism, but E2 is single-step mechanism. ये जो मैकेनिज्म मैंने यहां पर दिखाया, it is a single-step mechanism. It is E2 mechanism. लेकिन अगर एलिमिनेशन E1 से होगा, E1 is two-step mechanism. E1 मैकेनिज्म में पहले कार्बोकैटायन बनेगा, पहले कार्बन और ब्रोमीन के बीच में बॉन्ड ब्रेक होगा, कार्बोकैटायन बनेगा, फिर H निकलेगा. मैं रिपीट करता हूं ताकि कंफ्यूजन ना रहे, क्योंकि मैंने लिखा था इधर E1 को सिंगल स्टेप. E1 is two-step mechanism. E2 is single step mechanism. Just as SN1, it is a two-step mechanism. Similarly, E1 is a two-step mechanism. अगर एलिमिनेशन E1 मैकेनिज्म से होगा तो पहले कार्बोकैटायन बनेगा, फिर H निकलेगा, वो गया E1 मैकेनिज्म. लेकिन अगर एलिमिनेशन E2 मैकेनिज्म से होगा तो E2 मैकेनिज्म इज अ सिंगल स्टेप मैकेनिज्म. मैंने यहां पर E2 मैकेनिज्म दिखाया, हाइड्रोजन और ब्रोमीन को इकट्ठे निकाला, डिहाइड्रोहैलोजिनेशन, लॉस ऑफ हाइड्रोजन एंड हैलोजन. So, elimination can take place by E1, elimination can take place by E2. E1 two-step mechanism, E2 single-step mechanism. Now the question is, if elimination takes place by E1 mechanism, E1 mechanism is a carbocation mechanism. E1 mechanism is a carbocation mechanism. Then what will be the order of reactivity? Order of reactivity for E1 mechanism is tertiary, secondary, primary. For E1 mechanism, order of reactivity will be tertiary, secondary, primary, because E1 mechanism involves formation of carbocation. If you start with tertiary alkyl halide, you will get tertiary carbocation, and that will be formed readily. If elimination takes place by E2 mechanism, now it is important. If elimination takes place by E2 mechanism, the order of reactivity is again tertiary, secondary, primary. Why? If elimination takes place by E2 mechanism, order of reactivity is again tertiary, secondary, primary, because elimination product is always alkene. Elimination product is always alkene. And when you start with tertiary alkyl halide, you will get more substituted alkene. When you start with tertiary alkyl halide, you get more substituted alkene. ये जो alkene है इधर, it is more substituted because it has got two methyl groups. You can see it like this. असल में ये इथीन और इसके साथ आप इन दो का कंपैरिजन करो, CH2 यहां पर भी है CH2 डबल बॉन्ड C। अब ये जो CH यहां पर असल में H होना चाहिए था, यहां पर भी H, लेकिन इस H के बदले मिथाइल, इस H के बदले भी मिथाइल। So there are two substituents. It is highly substituted alkene. Highly substituted alkene is highly stable. Let us recapitulate it. Alkyl halides can undergo elimination also. What is elimination also called as? Dehydrohalogenation. Loss of hydrogen and halogen. Elimination can take place by two mechanisms, E1 and E2. If elimination involves E1 mechanism, it is a two-step mechanism. पहले कार्बोकैटायन बनेगा फिर H निकलेगा. So E1 mechanism is carbocation mechanism. Therefore order of reactivity, best alkyl halide कौन सा है जिसको elimination हो सकता है by E1 mechanism? That is tertiary alkyl halide. Because starting from tertiary alkyl halide, you get tertiary carbocation, which will be readily formed. But if elimination takes place by E2 mechanism, again the order of reactivity is same. Why? Because elimination product is always alkene, and starting with tertiary alkyl halide, we get more substituted alkene. More substituted alkene is more stable, because 11th में पढ़ा होगा that more substituted alkene will be having more hyperconjugation forms. More substituted alkene will be having more hyperconjugation forms. Since इसके hyperconjugation forms ज़्यादा है, therefore it's highly stable. Therefore, we have got like this now. This is alkyl halide plus nucleophile. Now it's very important. Alkyl halide plus nucleophile can undergo substitution, can undergo elimination. Elimination can take place by SN1. It can take place by SN2. If elimination takes place by SN1, order of reactivity is tertiary, secondary, primary. When alkyl halide reacts with nucleophile, it can undergo substitution or elimination. If substitution takes place by SN1 mechanism, order of reactivity is this. If substitution takes place by SN2 mechanism, order of reactivity is this. Now, elimination can take place through E1 or through E2. If elimination takes place by E1, order of reactivity is this. If it takes place by E2, order of reactivity is same. Now this is very important. When alkyl halide is made to react with nucleophile, it can undergo substitution, it can undergo elimination. If substitution takes place by SN1 mechanism, the best choice is tertiary alkyl halide. But when it undergoes substitution by SN2, the best choice is primary alkyl halide. Magar for elimination reactions, order of reactivity is same. That means whenever alkyl halide is made to react with nucleophile, there is a competition between two types of reactions, substitution and elimination reactions. When alkyl halide is made to react with nucleophile, there is a competition between substitution and elimination. Now the question is, if substitution is required, which alkyl halide should we start with? अगर हमें substitution reaction चाहिए, हम लोग चाहते हैं कि substitution dominant रहे on elimination, तो best choice, best substrate for substitution reaction will be, for substitution reaction, best choice is primary alkyl halide. Best choice is primary alkyl halide. Why? Zara explain karo. This is because when you start with the primary alkyl halide, इसको सब्स्टिट्यूशन होने का एक चांस है बाय SN2 मैकेनिज्म, लेकिन एलिमिनेशन होने का इसको कोई चांस नहीं है, बिकॉज एलिमिनेशन में तीसरे नंबर पर आता है, वेदर इट इज E1 और E2, एलिमिनेशन में प्राइमरी अल्काइल हैलाइड लास्ट पर आता है। अगर आप चाहते हो कि सब्स्टिट्यूशन रिएक्शन हो जाए, स्टार्ट विद प्राइमरी अल्काइल हैलाइड, बिकॉज प्राइमरी अल्काइल हैलाइड को सब्स्टिट्यूशन होने का एक चांस है, दैट इज बाय SN2 मैकेनिज्म, लेकिन एलिमिनेशन होने का इसको कोई चांस नहीं है, एलिमिनेशन में लास्ट पर आता है दोनों मैकेनिज्म्स में। लेकिन इफ यू वांट elimination reaction to take place, then you should start with tertiary alkyl halide, because when you start with the tertiary alkyl halide, इसको सब्स्टिट्यूशन होने का एक चांस है, मगर एलिमिनेशन होने के दो चांसेस हैं। So you should remember it. For substitution reactions, substrate of choice is primary alkyl halide. When you take primary alkyl halide, substitution strongly competes with elimination. Therefore, substitution takes place. But if you take tertiary alkyl halide, elimination strongly competes with substitution. So, जो इस लेक्चर का जिस्ट है, that is, alkyl halides undergo two types of reactions: substitution reactions and elimination reactions. But as far as choice of substrate is concerned, the best choice for substitution is primary alkyl halide, and best choice for elimination is tertiary alkyl halide. For elimination reactions, we should always start with tertiary alkyl halide. Today we have discussed the choice of substrate. In the second lecture, we will discuss the role of solvent for these reactions, and of course temperature. Important is role of solvent, which will be in the next lecture, and the chemical reactions of substitution reactions of alkyl halides. Thank you very much.
Thanks for watching.